Hello everyone, welcome back to Spectrum classes. This is our part 5 video on the topic metallurgy, and in this video we are going to discuss about the extraction of metals from ores, and this extraction of metals from ores will be discussed based on the reactivity of the metal. This video is very important for class 10th, class 12 material science students, and this video is also very important from the IIT JEE, NEET and other competitive exams point of view. So let's start with the ores of metals and extraction of metals from their ores. In our previous videos, we have just discussed about that metals are categorized into 5 different categories based on their ores. But here in this video, we are going to discuss about the broad categorization of these metals into highly reactive metals, moderately reactive metals and less reactive metals. So these highly reactive metals and moderately reactive metals are supposed to be present in their ores, whereas less reactive metals are supposed to be present in their native states or in the sulfide ores. From their ores of these metals, they are converted first into metal oxides by different processes like calcination, roasting, smelting, etc. And those metal oxides are further converted to the metals, whether they are of pure metals or they are converted into impure metals. If we are getting the impure metals, then these impure metals are further purified to get the pure metals, right? So this is what the process which we are going to follow over here. So this conversion of metal oxide to metal is termed as reduction and oxidation. So as I told you earlier that reduction reaction can't be occur alone. It is always accompanied with the oxidation. That is why we are calling them redox reactions. RED stands for reduction and OX stands for oxidation. RED red. So that is why I have just shown it with the red color. What is called reduction and what is called oxidation? So gain of electrons, addition of hydrogen or removal of oxygen. So any of the definition we can use. Similarly, oxidation is defined as either loss of electron, removal of hydrogen or addition of oxygen, just opposite to the reduction. One more thing, in reduction, the oxidation state of the metal will converted into high to low oxidation state. And why high to low oxidation state? Because on gain of each electron, there is addition of minus. So if we are having plus 3, then addition of 1 electron, we will get plus 2. Plus 3 minus 1 is equal to plus 2. Similarly, if we are having plus 3 and we are adding 3 minus, then we are having 0. On addition of electrons, oxidation state converted from high to low oxidation state. Similarly, for oxidation, it converts from low to high oxidation state. That we are going into the next slide. So I hope you understand this redox reactions or reduction as well as oxidation term. Now we are further going to describe these metals based on their reactivity. And in the earlier videos, that is in the metals and non-metals, there I gave the mnemonics to remember this reactivity series of metals. So here these are more reactive metals, these are moderately reactive metals, these are again moderately but less reactive metals, and these metals are present in their native forms. On going down this series, reactivity decreases. The next is these more reactive metals have high affinity towards oxygen as well as for chloride. So these metals can't be reduced by other elements. Their electrolytic reduction is done to get or to convert their metal oxides and metal chlorides from their molten state to pure metal. Whereas for moderately reactive metals, here reduction of metal oxides will be done by carbon or aluminium as a reducing agents, right? Why it is so, that I will just tell you about. And here we are having why it is so called. First, I will give you a brief overview about the less reactive metals. The sulfide ores of these metals are first roasted to convert their oxides, and on further heating, these metal oxides further converted to the metals, or the reduction of these metals is done by heat alone. Here we are having three different methods for the reduction of metals. And these gold and platinum metals are found in their native states. So what you have seen over here, electrolytic reduction for highly reactive metals, reduction by carbon and aluminium for moderately reactive metals, and heating of sulfide ores in air, and on their further heating convert that into metals. There are three different reduction methods for these metals based on their reactivity. The next thing which I bring to your notice is that these metals can be reduced by the carbon. The concept behind this, we have already discussed the displacement method. Suppose these are the more reactive metals and these are represented by metal A. Like in alphabetical order, A comes first. So more reactive metals are represented by A, that is more reactive. And if we are having the metal oxide of less reactive metal, then metal A can have more affinity towards this oxygen. So metal A can reduce this metal oxide B to metal and itself get converted to metal oxide of A. So this is the displacement method which we have already discussed in the physical properties of metals and non-metals for class 10th video. Here we are having the carbon before this zinc, but this carbon is lower in this reactivity series than the manganese metal. So what inference we have made over here? First question, whether manganese can be reduced by carbon? So no, because carbon is at lower end of the reactivity series than this manganese metal. So carbon cannot reduce this manganese to metal by its metal oxide. However, aluminium is higher in reactivity series than this manganese. So aluminium can reduce the metal oxide of this Mn to metal Mn. So here Mn cannot be reduced by carbon, but it can be reduced by aluminium. Similarly, zinc can be reduced by the carbon simply, and using carbon is economically viable. And similarly, other metals can also be reduced by this carbon or carbon monoxide. That we are going to discuss in the next slides. This is the basic concept behind the reactivity order of these metals for reduction of metal oxides of moderately reactive metals. Why the reduction of these metal oxide can be done by aluminium and carbon. For some of the metals, sometimes magnesium, calcium, sodium, potassium is also used, but that are very specific cases. Here we are not going into that. And this thing we can understand through this flowchart. So first, concentration of ores can be done by different methods, as we have already discussed in one of our video, that is gravity separation, froth flotation method, magnetic separation and leaching. These concentrated ores based on the reactivity series of the metals can be categorized into these three categories, that is highly reactive metals, moderately reactive metals and less reactive metals. And we will discuss one by one. Since highly reactive metals can't be reduced by carbon and aluminium, I already explained the reason behind that, because these metals have high affinity towards the oxides and chlorides than the carbon and aluminium. Therefore, these metals can't be reduced by calcium and aluminium. So their electrolytic reduction is done for their molten oxides and chlorides. And in this method, we are getting the pure metal. Whereas for moderately reactive metals, we are having carbonate ores, and these ores by calcination converted to metal oxides. And these metals also have their sulfide ores, and those sulfide ores by roasting converted to metal oxides. And these metal oxides further reduced to metals by using carbon or aluminium. By this process, we get impure metals, and that is further purified by different methods to get the pure metal based on the properties of the metal. For moderately less reactive metals, we are having sulfide ores, and these sulfide ores by roasting and by heating alone get reduced to impure metals, and these impure metals further purified to get pure metals. So this is the flow chart, and here we have already discussed about the terms calcination, and this is done for the carbonate ores, while roasting is done for the sulfide and arsenic ores, how we are getting the metal oxides and how these metals get converted to metals, whether they are impure metals, If we get impure metals, then we can purify them to get pure metals. I have also discussed about the term smelting. If these metal oxides having infusible impurities, then we add flux to them, and that flux converted the infusible impurities to the fusible mass, which is known as slag, and this process is known as smelting. It is depending on the nature of the metal as well as presence of the impurities. I hope you understand in easy and simple manner. The next thing, we are going to discuss these processes one by one by taking different examples.